scenes, work, word window, work energy and power topic, work in physics subtopic 1. Definition and dependence. Work is said to be done when a force causes displacement in the direction of force. Formula: work, W, is equal to force, F, times displacement, S, times cos, theta, depends on magnitude of force, distance moved, direction between force and displacement. Example: lifting a book, force and displacement in same direction. Subtopic 2. Units of work. C. G. S unit. Erg 1 erg is equal to 1 dyne times 1 centimeter. S. I. Unit. Joule. J. 1 J is equal to 1 N times 1 M. 1 J is equal to 10 erg. Example: if a force of 1 N moves a body by 1 M, work is equal to 1 J. Subtopic 3. Gravitational unit of work. Misspelled G. Misspelled C. Misspelled G. Misspelled S. 1 g.f.cm is equal to 980 erg S. I. 1 misspelled kg/m is equal to 9.8 J. Example: lifting 1 kg by 1 m on Earth, work is equal to 9.8 J. Subtopic 4. Work done. Formula: W is equal to Fs cos theta. If the direction of force and displacement differ, W is equal to F times S times cos theta. Theta is equal to angle between force and displacement. Example: theta is equal to 0 degree, full work done, cos 0 is equal to 1, theta is equal to 90 degrees, no work done, cos 90 is equal to 0, theta is equal to 180 degrees, negative work, cos 180 is equal to 1. Diagram trick: think of triangle showing displacement and angle. Subtopic 5. Conditions for work done. Condition: work done, no displacement, 0 force. Displacement: theta is equal to 90 degree, 0 force opposes displacement, negative force in direction of displacement. Maximum examples: pushing a wall, no displacement, no work. Carrying load horizontally, theta is equal to 90 degrees, no work. Lifting object, work done against gravity. Subtopic 6. Graphical work. Variable force. Area under force versus displacement graph is equal to work done. Work by gravity is equal to misspelled mgh. Mass times g times height. Example: climbing stairs or taking an elevator, same work. Subtopic 7. Units in powers of 10. Unit value: 1 kilojoule, 10 superscript 3 J, 1 megajoule, 10 J, 1 gigjoule, 10 J. Remember key concepts: W, U, F, G, C, A, G. W work is equal to force times displacement times cos theta. U units: joule, psi, erg, c.g.s. F force direction affects result. Theta is equal to an. Le. G gravitational work is equal to misspelled mghc. Conditions: 0, positive, negative work. Area under graph is equal to work done G gigjoule, megajoule, kilojoule. Big units. Topic: energy. Subtopic 1. Definition: energy is the capacity to do work. It is a scalar quantity, has magnitude, no direction. If work is done, energy decreases. If work is received, energy increases. Example: a charged battery can light a bulb. Does work energy used. Subtopic 2. Units of energy system. Unit C. G. S. Erg S. I. Joule. J. Bigger units: watt hour, misspelled WH, kilowatt hour, kWh. 1 kWh is equal to energy used by 1 kilowatt device in 1 hour. Subtopic 3. Energy conversions and relations. 1 kWh is equal to 1000 W times 3600 S is equal to 3.6 times 10 J. 1 calorie is equal to 4.18 J. 1 EV is equal to 1.6 times 10 superscript 1 J. Trick to remember. EV atomic level energy misspelled cold heat food energy kWh electricity bill energy. Subtopic 4. Forms of energy and sources. Form of energy source: chemical fossil fuels, electrical electric charges, nucleus of atoms, heat fuels, sound vibrating bodies, light sun, electricity solar sun, mechanical rest or motion, state. Example: chemical energy in petrol powers a car. Solar energy powers solar panels. Electrical energy from batteries powers a torch. Remember forms of energy. CENSHLSM. Can every nice student help learn solar mechanics? C. Chemical. E. Electrical. N. Nuclear. S. Sound. H. Heat. L. Light. S. Solar. M. Mechanical. Topic. Types of energy. Subtopics and short explanations. Solar energy misspelled energy from the sun by nuclear fusion. Earth gets ~1 kgm superscript 2 sec used via solar cells panels to generate electricity. Example: solar panels on rooftops power homes. Heat energy comes from burning fuels, coal, wood, gas, converts to mechanical energy in engines. Example: steam engine runs by heat from coal. Light energy misspelled energy that enables us to see objects. Example: sunlight helps us see during the day. Chemical energy stored in fuels and released when burned. Example: petrol in cars, food in our body. Hydro energy misspelled energy from flowing moving water. Example: dams generate electricity from water flow. Electrical energy produced when free electrons move, like rubbing dry objects. Example: bulbs glow using electric current. Nuclear energy misspelled energy from nuclear fission or fusion. Mass converted to energy. E is equal to mc superscript 2. Example: atomic power plants. Geothermal energy from nuclear reactions inside Earth's crust. Example: hot springs and geysers. Wind energy misspelled energy from fast-moving air. Example: windmills generating electricity. Mechanical energy misspelled energy due to an object's motion or rest, kinetic or potential. Example: moving car or compressed spring. Remember 10 types of energy. Some hot lions can hunt every naughty giant with mighty roar. S. Solar. H. Heat. L. Light. C. Chemical. H. Hydro. E. Electrical. N. Nuclear. G. Geothermal. W. Wind. M. Mechanical. Topic. Types of mechanical energy. Subtopic 1. Potential energy. PE. Definition: energy possessed by a body due to its position or configuration. Formula: P is equal to misspelled mgh, m is equal to mass, g is equal to gravity, h is equal to height. Types of PE: gravitational PE, stored due to height above ground. Example: water stored in a dam. Elastic PE, stored due to compression stretch. Example: compressed spring. Subtopic 2. Kinetic energy. K. Definition: energy of a moving object due to motion. Formula: K is equal to a half mv superscript 2, m is equal to mass, v is equal to velocity. Example: rolling stone, moving car, bullet in motion. Subtopic 3. Relation between K and momentum. P. Momentum, P is equal to mv, K is equal to P superscript 2m. Tip. Useful when velocity is unknown but momentum is given. Subtopic 4. Work energy theorem statement. Work done by force is equal to increase in kinetic energy. Proof. From equations of motion and Newton's laws. W is equal to F times S, misspelled S is equal to V superscript 2 U superscript 2. To a final result. W is equal to a half mv superscript 2. A half mu superscript 2. Application. Used to calculate how much work is needed. D to speed up or stop a body. Subtopic 5. Forms of kinetic energy. K. Type example: translational car on road, bus on highway, rotational fan blades, earth rotating vibrational tuning fork, sewing machine needle trick. Think. Tr. V. Translational, rotational, vibrational. Remember mechanical energy topics. Potato gave K and MRV motion. Potato potential energy gave gravitational and elastic K kinetic energy and MRV momentum relation. Rotational, vibrational topic. Law of conservation of energy and transformation. Subtopic 1. Law of conservation of energy. Misspelled energy cannot be created or destroyed, only transformed. Total mechanical energy, K plus P, of an isolated system remains constant. Formula. T. E is equal to K. E plus P. E is equal to constant. Subtopic 2. Real-life examples. Simple pendulum at highest point, P maximum, K is equal to 0 at mean position, K maximum, P is equal to 0. Total energy stays constant throughout motion. Example: swinging pendulum in a clock. 2. Freely falling body at top, P is equal to misspelled mgh, K is equal to 0 midway, P, K. Total is equal to misspelled mgh just before ground, P is equal to 0, K is equal to max, is equal to misspelled mgh. Example: stone falling from a building. Subtopic 3. Energy transformations. Mechanical to heat, rubbing hands, sound tuning fork, electrical generator, dynamo. Heat to mechanical heat engine, light, electric bulb, electrical thermoelectric effect, chemical endothermic reaction. Light to electrical photo cell, chemical photography. Note: mechanical energy often converts first to kinetic energy, then to other forms. Remember, mechanic he changes lights, M mechanical E energy, C converts to H heat, C chemical L light, S sound, E electrical. Topic: power. Subtopic 1. Definition: power is the rate of doing work. Formula: P is equal to misspelled work time is equal to WTP is equal to \frac work time is equal to \frac W. T. Power is a scalar quantity. Example: a fast runner uses more power than a slow walker to cover the same distance. Subtopic 2. Units of power system. Unit: S. I. Watt. W. C. G. S. S1 watt is equal to 1 joule sec. 1 kilowatt is equal to 1000 W. 1 horsepower, HP, is equal to 746 W. 1 megawatt is equal to 10 W. Subtopic 3. Expressions for power. If W is equal to F times S, W is equal to F times S, then P is equal to F times cent is equal to misspelled F times misspelled VP is equal to \frac F times S. T is equal to F times V. Since velocity is equal to displacement time. Example: more powerful machines lift heavier loads faster. Subtopic 4. Difference between work and power. Work power total energy transferred rate at which energy is transferred depends on force and displacement depends on work and time taken unit, joule, J, unit, watt, W. Subtopic 5. Difference between energy and power. Energy power total capacity to do work. How fast energy is used does not depend on time, depends on energy used per second unit, joule, J, unit, watt, W. Remember, Watt HP, W work E energy T time H horsepower P power trick. Power is equal to work done fast, WT. More energy in less time. Topic: Energy sources and production of electricity. Subtopic 1. Requirements of a good source should give adequate energy for a long time. Must be safe, economical, easy to store and transport. Example: solar energy fits this, available daily, easy to harness with panels. Subtopic 2. Types of energy sources. Renewable sources can be used continuously without exhaustion, also called non-conventional sources. Can be regenerated. Examples: solar, wind, hydro, geothermal, nuclear. Non-renewable sources. Limited supply, will exhaust with overuse. Also called conventional sources. Cannot be regenerated. Examples: coal, petroleum, natural gas. Subtopic 3. Judicious use of energy. Non-renewable sources are limited. Careless use may cause crisis. Energy should be used only where needed, for essential purposes only, with minimal wastage. Renewable options like solar and wind should be promoted. Forest cutting must be balanced with replantation. Real-life example: using solar cookers or LED lights at home saves fossil energy. Remember, RN and judge are renewable and non-renewable and nuclear. As renewable, judge judicious use of energy. J, justified use. U, use when needed. D, don't waste. G, go green. E, encourage renewables. Topic: Production of electricity. Subtopic 1. Solar cell and solar panels. Solar cells are made of semiconductors, e.g., silicon. Sunlight creates a potential difference, produces direct current, DC. Cells are arranged in solar panels to produce sufficient electricity. Advantages: no maintenance required. Long lifespan. Zero pollution. Ideal for remote areas. Disadvantages: high initial cost. Low conversion efficiency. Cannot power heavy appliances directly. Example: rooftop solar panels in villages or schools. Subtopic 2. Solar power plant uses large curved mirrors to concentrate sunlight. Heat converts water to steam, which rotates turbines. Example: solar thermal power stations in Rajasthan. Subtopic 3. Wind energy. Wind turbines rotate and drive wind generators. Each turbine produces a small amount, so many are used in a wind farm. Advantages: renewable and non-polluting. Works well in open, windy areas. Speed greater than or equal to 15 km per hour. Limitations: high setup cost. Wind not always available. Regular maintenance needed. Example: wind farms in Gujarat or Tamil Nadu. Subtopic 4. Hydroelectricity uses energy of flowing water, collected in dams, to rotate turbines. Advantages: no pollution. Controls floods, irrigates fields. High energy output. Limitations: high initial dam cost. affects ecosystems and people displaced from dam areas. Example, Vakra Nangal and Sardar Sarovar dams. Remember, SWH safe water harnessed, S solar W wind H hydro for advantages, use, no pollution, long use, low cost later, for disadvantages, high start, low output, needs maintenance. Topic: Nuclear energy. Subtopic 1. What is nuclear energy? Nuclear energy is released when atomic nuclei split, fission, or combine, fusion. Nuclear fission, a heavy nucleus, e.g., uranium-235, splits into lighter nuclei, releasing energy. Nuclear fusion, like nuclei, e.g., hydrogen, combine under high pressure and temperature to form a heavier nucleus, releasing more energy. Example, nuclear reactors use fission of uranium-235 to produce electricity. Subtopic 2. Energy conversion process. Heat from fission is used to boil water produce steam. Steam rotates turbines, which rotate generators to produce electricity. Based on Einstein's relation, E is equal to mc2. E is equal to mc2 where mass lost is converted to energy. Subtopic 3. Advantages. Huge energy from small amount of fuel, e.g., uranium. Continuous supply once fuel is loaded into the reactor. Useful when fossil fuels are limited. Example, 1 nuclear pellet is equal to energy of 1 ton of coal. Subtopic 4. Limitations. Not clean, produces harmful radioactive waste. Storage and disposal of waste is risky. Fusion is safer but not practically feasible yet due to high temperature needs. Example, nuclear accidents like Chernobyl and Fukushima show the risk. Remember, fuel, F fission and fusion U uranium gives unmatched energy. E is equal to mc superscript 2, mass energy conversion, L limit, radioactive waste and leakage risk. New notification